Welcome to Center Math's Problem of the Week. For this week's problem, we want to consider the polynomial x to the fourth minus x cubed minus 3x squared minus x plus 1. And consider if x equals 3 to the n, we want to prove for infinitely many n that this polynomial is going to be a composite number. So we're going to consider 3 to the n modulo 5. And we're going to, so 3 to the n modulo 5, note that 3 to the n is congruent to 2 modulo 5 for infinitely many n. 3 to the n generates the whole multiplicative group, the 1, 2, 3, 4, 5, not going 0 modulo n, so 1, 2, 3, 4. So 3 to the 3 is 27. 27 is 25 plus 2, so it's congruent to 2 mod 5. And 3 to the 5, from Fermat's little theorem, we know it's congruent to 1, so 3 to the 8 is going to be congruent to 2, 3 to the 13 is going to be congruent to 2, it's going to be congruent to 2 for infinitely many n. And so saying if we assume 3 to the n is congruent to 2, if we assume 3 to the n is congruent to 2, and we plug this in here, we can see that something nice happens. So we see if we assume 3 to the n is congruent to 2 mod 5, and then we look at x to the fourth, where x is 3 to the n congruent to 2, x to the fourth is going to be congruent to 1, x cubed congruent to 3, 3x squared congruent to 2, and then x, of course, congruent to 2. And so if we plug all these back in here, we're going to see that our polynomial is in fact going to be congruent to 0 mod 5 when 3 to the n is congruent to 2. And since this is 3 to the n is congruent to 2, for infinitely many n, this polynomial will be composite for infinitely many n, since it grows and goes to infinity as n goes to infinity. And that solves our problem. Thanks for watching. Please check out our blog, check us out on centermath.org, and follow us on Facebook and Twitter. Thank you.